Hi, this is Sung, the Principal and Director of Sky Academy, and we've been looking at the circle and the equation of a circle, and there are some tricky bits with the circle, especially when it comes to working out the domain and the range of a circle, especially when you're dealing with the halves of a circle or the semicircle, all right? So I just want to go through this with you, and basically I've titled this episode as the semicircle, but let me show you what I mean, okay? It might not make sense to you now, but let me just go through what I mean. The equation of a circle is x squared plus y squared equals r squared. Now, that can be rearranged so it looks like this. Y squared is equal to r squared minus x squared. Does that make sense? It can also be rearranged so x squared equals to r squared minus y squared. Now if we find the square root of both sides, or we undo the square of both sides, not technically finding the square root, what we find is that y is equal to the square root of r squared minus x squared, right? Not quite, because what we've also got to factor into consideration is that there would be the positive and the negative square roots, all right, or the negative answers to that equation, right? Now, what you'll find is that both the positive and the negative forms represent different things. So we know that in a circle, y squared equals to r squared minus x squared is simply just a rearrangement of x squared plus y squared equals r squared, which is a circle, right? Now, let's think about what y equals to positive r squared minus x squared might mean. Well, what that means is that y can't be negative. Now, in this circle, which part of the graph represents all the parts where y can't be negative, in fact where y is positive? Yeah, it's this bit here, isn't it? Okay, so the red bit represents positive, well, y equals to positive square root of r squared minus x squared, whereas how would you represent the bottom half of the circle? All right. The bottom half of the circle, let's represent it with blue, would be represented by y equals to, well, obviously it's the negative part, negative square root of r squared minus x squared. Now, on the other side, we've got the same function x squared plus y squared equals to r squared being represented as x squared equals to r squared minus y squared. You undo the square and you've got x equals to r squared minus y squared. The square root of that. Yep. Now, remember also we have to take into consideration the positive and the negative answers. So we do that, which means that we're left with a circle, right, where the positive half would be all the parts where x is positive. Where is x positive? Well, it's positive from here onwards, isn't it? So the red half, that bit there, would be where x is equal to positive root of r squared minus y squared. Yes? And the blue half, well, I'm gonna color that in blue. This half here will be x is equal to negative r squared minus y squared. Does that make sense? Now, we need to also take into consideration the domain and range of this function, okay? The domain of this function, right, will be between positive and negative r, domain, would be between negative R and positive R, and the range would be between 0 and R. Does that make sense? Yep. Whereas the domain and range for that would be the same. The domain would be the range. Would be the same. But the range would be between negative R and 0. Does that make sense? Yep. Likewise on this side, the domain of this, so I've written capital D and F for the function. The domain of the function, df, would be, what would it be? X between 0 and R, and the range of the function will be from negative R to positive R. Yep. And on this side, the domain will be, let me write it another way. The domain will be from negative R to 0, and the range would be from negative R to positive R. Do you remember this notation? Yep. Well, we're going to use that one for this because I've got less space to write in. But just we need to remember that the domain and the range will be restricted by each of these different semicircles. Okay, so we need to bear that in mind. All right. Well, thank you very much for watching. We'll end this episode here.